Exponential and logarithmic equations. So this is how we're going to start using logs and exponents to solve um, solve the equations instead of just messing around with the properties. So an exponential equation is just an equation that has a variable as an exponent. So 3 squared equals x isn't really considered an exponential equation, even though there's an exponent in it. You need a variable in that exponent. So a couple of keys, you want to try to write them, if you can, so that all the bases are the same. Because if you had 3 to the x equals 3 to the 12th, then x would have to equal 12. And the other thing that you can do is to take a logarithm of both sides. So if you do the log of both sides, those are also going to be equal, and then you can oftentimes mess around with that and work things out because of the properties of logs that we've been dealing with. So as a for instance, look at these 3 examples. We have 3 to the 2x equals 27. So if the first thing you try to do is get the bases the same, 27 is a nice number because that's 3 cubed. So you get 3 to the 2x is equal to 3 cubed. Therefore, 2x equals 3, so x has to be equal to 3 halves. And you can plug that in and check it. Now here we have 7 to the negative x equals 21. Well, there's no way to write 21 as a power of 7. So we can't come up with the same base, but we can take the log of both sides. And when we do that, we get the log of 7 to the negative x equals the log of 21. By the property of logarithms, the power property, we get negative x times the log of 7 equals the log of 21. Divide both sides by the log of 7, so we get negative x equals the log of 21 divided by the log of 7. And then to solve for x is going to be equal to the opposite of the log of 21 divided by the log of 7. So if we just punch that into the calculator real quick, we get the log of 21 divided by the log of 7 is approximately 1.56. That's approximately 1.56, and that would have to be negative because of the negative outside. So that's all there is to that one. Same deal on part C. We have 2 to the 3x. There's no way to write 15 as the power of 2, so we're going to have to deal with taking the log of both sides. Log of 2 to the 3x equals the log of 15. Power property, 3x comes out front, times the log of 2, which equals the log of 15. So we get the 3x equals the log of 15 divided by the log of 2. And then divide both sides by 3. So x is going to be equal to really the log of 15 over 3 times the log of 2, which is really the same as dividing by 3. So x equals, we'll grab the calculator and we'll punch in the log of 15 and divide that by 3 times, divide that by, 3 times the log of 2. And enter, and we get approximately 1.30. So approximately 1.30. This is that. No, that's really all there is to it. If you can, it's a lot easier just to write it as basis, but if you can't, you take the log of both sides. Now notice I just chose the common log. We could have done any other base, but I think the common log base 10, works out the best. Logarithmic equation, as you might guess by the name, is logs that contain a variable. So we can solve them by using the property of logs and exponents and kind of go back and forth between those. So if we take a look here, we have solve 3 is equal to the log of 8 plus 3 times the log of x. We can kind of work through this and figure this out. So if we get the 3 equals log of 8, we want to deal with that 3 times the log of x, so that's the same as saying the log of x cubed. And here we have an addition, so that's the same as multiplication. So we get 3 is equal to the log of 8x cubed. So that's the log base 10 of 8x cubed equals 3. It's the same thing as saying 10 to the third equals 8x cubed. 10 to the third is 1,000 equals 8x cubed. So we just divide both sides by 8. So we get x cubed equals 125. And the cube root of 125, hopefully you can all figure that one out. It's just 5, because 5 cubed is 125. So x equals 5. And you can plug that back in and check it out if you'd like. And I think you'll find that that works out quite nicely. Same situation in this one for 3b. Just switch colors here. So we get 2 times the log of x. Well, that's the same as writing the log of x squared minus the log of 4 equals 0. It's subtraction, so that's the same as division. So that's like saying the log of x squared divided by 4 equals 0, which is really the same thing as saying 10 to the 0 power equals x squared over 4. By the properties of logs, properties of exponents. So x squared over 4, 10 to the 0 is just 1. So multiply both sides by 4, x squared equals 4. So x equals plus or minus 2. And we have to check and make sure they'll both work. And I think if we try to throw in that log of -2, you might have some issues. So you can try that on your calculator, and you're going to get something that says non-real answer. So when you try to do the log of a negative number, that's not going to quite work out for you. And if you think about what the graph looks like, that should make sense. Therefore, x equals 2 is our answer. And that's all she wrote. One of the other things that you can do is to use a table and a graph to solve them. So you can graph each of these. We're not going to go through all 3 of these examples. I don't think you necessarily have to use a table and graph, but certainly knowing how to use it can help you sometimes with these problems. For instance, on 4a, I don't think that I would use a table and graph approach, because it's 2 to the x. You could just rewrite that 4 as a power of 2. So 2 to the x equals 2 squared, right, which makes that multiplication. So then you'd have 2 to the x equals 2 to the 2x minus 2, and then set them equal and solve it out that way. But certainly it will work to throw it onto a table and then graph them to see where those possibilities lie, particularly with the greater than, less than situation. When you have inequalities like you do in 4b, that might be a decent approach. So I've attached an assignment for this section. It's on the calendar. So bring it to class, complete it, and then we'll be able to go from there. All right, I'll talk to you next time.